Indefinite integration through U substitution, number 27. I, I thought I was going to look out the window and say it just stopped raining, but it did not. It got old and couldn't see it, I guess. All right, U substitution. One thing I'm going to do is take a look at this, and it doesn't partition out. If this thing was flipped upside down, it would be a much easier problem. It's not, so we're going to do it this way. We're going to take a look at the bottom piece here. We're going to say let U equal this piece at the bottom. So U will equal this. U equals square root of x minus 3 du dx is equal to 1. Isn't that right? Isn't that true? Sure, that's absolutely true. Okay, just wanted to think my way all the way through that. Going to cross multiply and find out that 2 times the square root of x is equal to, 2 square roots of x du are equal to dx. And that's not very helpful. Not very helpful at all. So when I look at this, I was realizing I'm going to use this u substitution. This is going to go to u, and I'm not going to have anything in the denominator to cancel the thing out in the numerator. So what I'm going to do is just use this kind of different tactic when I notice this. Is I'm going to just resolve this a little bit. What I'm looking at is this right here and this right here. So I'm just going to solve this equation up here in terms of the square root of x. And it turns out that the square root of x is the same as, I'm just going to add 3 to both sides, is equal to u plus 3. So hopefully you can, well, you'll see. So let's resubstitute here. Actually, sorry. Let's substitute. We're not resubstitute. Let's substitute here, and it'll look like this, won't it? It will look like, oh, then that makes this 2 times u plus 3 here, doesn't it? Du is equal to dx. Sorry. All right, so substitute stuff in, right, and it should look like this, right? It will look like u plus 3, right, over u, right? Because remember, u plus 3 is the square root, square root of x, right? And so we're replacing this for this, and then we're going to take 2 times u plus 3 du, right? So everything is in terms of u now. That looks good. If you don't mind, I'm going to take this 2 out and put it out here as a constant multiplier. So I'm just going to put 2 times the indefinite integral. I'm going to take u plus 3 times u plus 3 is u plus 3 squared. So u plus 3 squared over u du, something like that, right? Then if you don't mind, we have to expand this. And when you expand this, you should get u squared plus 6u plus 9. Right, if you do that FOIL work, or however you want to describe that, but how did I get that? I multiplied this u plus 3 times this u plus 3 and got that. Now we can partition this out a little bit, right? We can just break this, into some pieces here, I think. So I'm going to let it look like this. I'm going to let it look like 2 times the indefinite integral of, you know what, if you don't mind, can we just do all this at one time? We'll be done with it. So this is what I'm doing here, just so you can see what I'm going to do. I'm going to take u squared over u is u, 6u over u is 6, and 9 over u is 9 over u, isn't it? So that's what these rewrites are, because save us some time here. Let's see how we're doing. Okay, so here we go. I swear I know what I'm doing. Thank you. All right, so I said that u squared over u is just u. Said that 6u over u is 6. Said that 9 over u is, well, 9 over u, isn't it? Du. Is that all right? So we have this all simplified out. And then if you don't mind, I'm just going to start to integrate here. So I'm going to integrate. Do my integration in orange. So it would be 2 times, well, this would be, go to u squared over 2, wouldn't it? So u squared over 2 plus 6u, isn't that right? 6u plus, this isn't, look, this is how I'm taking this. I'm taking this as 9 times indefinite integral of 1 over u. So that's, this 9 is this one, and 1 over u is ln, right? So here's 9, so 9 ln of u, okay, plus c. Is that all right? And then, whoa, why does that keep happening to me today? Then I'm going to go ahead and distribute this, I guess. I'm going to go ahead and distribute this 2 in. So I'm going to distribute this 2 in everywhere. So I'm going to distribute this 2 to here, to here, to here. You can distribute it to C if you want to, it won't help. Won't do anything. Okay, so this time this is just u squared, isn't it? 2 times this is 12u, isn't it? And then plus 18 ln of u plus c. I feel like we're almost there. We're really, really almost there. Then we just have to resubstitute, and this is the part that's actually really cumbersome, but to resubstitute. So resubstitute. That is, we substituted something in for u, we have to put that back in there. So we have this squared right here, and u is square root of x minus 3, so squared, plus, it says here 12, right, this 12 is this one, times u, but we remember that u is square root of x minus 3, plus 18 ln, that's all up there, right, but it says here there's some algebra left to do here. And there really is some algebra left to do here. And I'm going to leave you to do that algebra in the sake of shortening this video for you so you don't have to stay with me any longer. I'm sure you have more interesting things to do with your life than this. But I do want just to remind you quickly what we did here. Indefinite integration of with u substitution. In the examples number 25 and number 27 that we've done, what we've done is we've taken the denominator and we've turned it into our u. And as we've taken the derivative, we've ended up with some kind of weird looking stuff. And I just want to remind you that sometimes when that happens, that what you need to do is go back to this, right? Go back to this piece right here and see if you can't get this numerator piece in terms of u. It can really, really help out. Not always. I mean, I think what we're learning is that there are tons of patterns that we have to recognize, but when it gets kind of confusing, sometimes just step back away from it and see if there's not something simpler that we're missing. Okay, you guys? All right, good work, good work, good work.